All right, welcome back. Hononegah Honors, Algebra 2, Section 5.3. A little bit easier than Section 5.1 and 5.2. Those of you that have struggled over the past couple of sections, this one will be a little bit easier. Radical functions are literally that, functions that have radical expressions. An independent variable as the radicand. So you're basically going to put a letter under the radical. When the radical is a square root, the function is called a square root function. When the radical is a cube root, it's then called a cube root function. And yes, we'd have a quartic function or quartic root function and so on. But ultimately, these are the only two that we're going to deal with. And the biggest thing we have to worry about is the domain. When you have a square root, now you have a domain issue because you need that to be a positive value. So now your x values have to be greater than or equal to 0 in a square root function. But now when you do a cube root function, basically any number will work. So the domain is all real numbers. For a cube root function, where a square root function, you got to be concerned about the domain. So the next slide helps you out with that. So notice the domain is all values, x being greater than 0, and then the range is the actual picture. And so the picture starts off at 0, 0, and ultimately you graphed on the top side. It's actually a sideways parabola, so it's a half a parabola going to the right in this case. And notice in a cube root function, domain and range is all real numbers. So in a cube root function, anything goes, but in a square root function, the domain and range is really important. So here we go. Whatever is inside the radical must be greater than or equal to 0 in a square root function. So all the x values you're allowed to use in this particular function start with x being 1 and go greater than that. So any number that you use that's greater than 1 is fine. And now you'll notice that I picked 1, but then the other numbers I didn't just go like 2, 3, 4, 5, and so on, okay? Because I'm trying to get something that ends up being even. So when I put 1 into this particular question, 1 minus 1, and the square root of that is 0 plus 3. So the square root of 5 minus 1 is 4. Excuse me, 5 minus 1 is 4. Square root of 4 is 2, and 2 plus 3 is 5. And then 10 minus 1 is 9. Square root of 9 is 3, and 3 plus 3 is 6. Now, I need this right here is the domain. So now I'm going to actually graph it. So I have the point 1, 3, 5, 5, 10, 6. Notice it's like a ray. It only goes in one direction. It does not go in the other direction. I'm going to draw this and then I'm going to erase it. It does not go. That was interesting. It does not go the other direction. I don't know what's happening there. It does not go this way. So again, do not draw an arrow on both sides. It's kind of like a ray in geometry. Now the range. The range always starts with the y value, and in this case, the range has the y values going greater than 3. So it all depends if it's an upward side of the graph or if it's the downward side of the graph. So domain is where you start. Now I'm going to pull out a graphing calculator right now, and I'm going to type this in. So I've got y equals x minus 1. So I'm going to go to y equals, and I'm going to type in x, square root, second, square root, x minus 1 inside the radical. Now I got an arrow outside the radical, and then there was a plus 3. So I'm going to hit graph. So I apologize. I stopped there for a second. My window is messed up, so I should have known that. There it is. All right, so I went to Zoom 6 and made my window better again. Now, let's say I wanted points. So hit second, graph. And notice 0 was an error. Okay, I wasn't allowed to have 0, and I'm not allowed to have any number that's actually below 1, because remember, that was my domain. But I could have used 2, 4. That would have been another good point. 5, 5 was a good point. So notice that I'm trying to pick points. Now, is that always going to be able to happen? No, but I'm going to try to pick points that are integers to make my life a little easier with graphing. But technically speaking, you could use 3, 4.4, or 4, 4.7. So again, I'm not going to get picky on that. The only point that you have to have is the initial point for the domain. Like you have to have, basically it's the vertex of the sideways parabola, but you have to have the 1, 3. That's the only point that you have to have. So now let's go back. Let's try another one. Again, it's going to be a square root function. So the only thing inside the radical is an x, and that has to be greater than 0. This is my domain. So whatever is under the radical has to be greater than or equal to 0 in a square root function. Now, I'm going to do an XY chart here. And remember, 0 is the only number that you have to have. Every number beyond that, you can use whatever you want. So I can, let's say I wanted to use 4. Square root of 4 is 2. 2 times a half is 1. 1 plus 2 is 3. 0, sorry, I didn't go ahead and do that one. Now is when things get a little bit more challenging. You end up getting some fractional stuff here, like 1 ends up being 2.5, so that one's not too bad. 9 ends up being 3.5, so there are some other ones. 16 is actually the next one that ends up, but that's too far off the graph. So the square root of 16 is 4. 4 times a half is 2. So again, these are all ones that you could pick. The only one that you have to have is the 0, 2. For some reason, my board is only letting me go in black. So 0, 2, 4, 3. And again, the other ones like 9, 3.5, 1, 2.5, those are all options for you to graph. So now the domain was x is greater than or equal to 0. The range then, remember, it's all the numbers for y are going up from 2. So the range for y is y greater than or equal to 2. So the very first point is basically where the domain and the range are established. A little more challenge to this one. So I need the 3/2 x minus 1 to be greater than or equal to 0. So this is how you're going to come up with your domain. 3/2 x. So I end up getting x is greater than or equal to 2/3. So again, the only point that I am requiring you to have is the first point of the domain. So when you plug that one in, that's the point that you have to have. Every point beyond that is kind of up to you, and these are not very nice. I'm going to pull out a graphing calculator in just a second, but these points are a little bit more challenging. For instance, if you put 2 in, you're ending up with a negative square root of 2, which is not a nice decimal. If you put in 6, for instance, you're going to get negative square root of 8. So these are all different points that I can graph. And again, none of these end up being very nice. But, so I'm going to go to the graphing calculator just to look at it. So I go to y equals, and I have a negative square root 2/3 x minus 1, and I hit graph. So again, I'm going to go to my table, and I don't even see, all I see is starting from 1, I get error. So everything above that, I'm back, and I think I made a mistake, so I want to, yep, I did. So this should be 3/2. It won't change the picture much, but it was just a little bit weird on my table. When I was looking at the table, it wasn't right. All right, there you go. So now notice that 2 ends up being negative 1.44, and 6 ends up being negative 2.83. And so when I go to try to graph these, negative 1.41, and negative 2.82, negative 2.83, and then I think this was negative 1.41. So when I go to graph those, 2/3, 0, 2, negative 1, 6, 2.8, and there it is. It's going downward. So now the domain and the range. So the range starts at 0, but it goes less than or equal to 0. Notice all the numbers are below 0. So it's the bottom half of the parabola, not the top half of the parabola. Cube roots are actually a lot easier. You can pick any number you want when doing your XY chart. Your domain and range are going to be all real numbers. And so when you do this, you can pick anything you want. For instance, I could pick 0, and I get the cube root of 0, which is 0. I can pick 1, and the cube root of negative 8 would be negative 2, or the cube root of negative 1, which is positive 2. And I'm going to show you this on a graphing calculator in just a second, but it makes a zigzag. So literally it goes up, it goes down, it goes to the right. So it's a zigzag situation. And yes, this is a sideways. It's kind of like the cubics that we did in chapter 4 a little bit, except it's going the sideways direction. So let's do a graphing calculator, see what this looks like on a graphing calculator. So y equals cube root. Now, if I go into math, cube root actually has its own designation. It's the fourth one. So I have the cube root of negative 8x graph. And notice it made the zigzag. Next, another cube root. Here's what I would tell you on all these cube root type questions. Yes, the domain is always going to be all real numbers, and the range is going to be all real numbers on a cube root graph. However, I always tell everybody, always try to get the 0. Like the value that makes this part of it 0 will always be a good number to go ahead and do. And then cube root of 1 is always a good number. Cube root of 8 is always a good, or excuse me, cube root of 8 is always a good number. So what if I put negative 3 in? The cube root of 1 is 1, and 1 times a half. And so the cube root of, let's say, negative 5 would then be negative a half. So those are good numbers. 4 is a good number, because when you get the cube root of 8, you get 2, and then a half times 2 would be 1. Negative 8, so this one's going to be a little harder, negative 12, then I get negative 1. So when I graph this, negative 4, 0, 4, positive 1, and then negative 12, negative 1. So this is a pretty skinny graph, but you should really always find when the cube root is actually 0, because that's where the zigzag actually occurs. Like it's downward and then it's upward on that case. So let's go back to the graphing calculator. Let's type this in. Let's see how it goes. So now y equals 1/2 cube root of x plus 4. Graph. So the graphing calculator is going to come into play in this particular chapter still. You can still use that to help you. Your homework assignment is out of the book. Or excuse me, let me try it again. Your homework assignment is a worksheet. Please make sure if you have any questions, you talk to a teacher. But this is all about graphing square roots and graphing cube roots. Good luck.